As I record this, there is a storm in the western Pacific with a 145-mile-an-hour core, and it is moving toward Japan. Super Typhoon Dolphin. On Saturday morning Japan time, it was about 2,000 miles east-southeast of Kadena Air Base, running northwest at 14 miles an hour, gusting to 175. The Joint Typhoon Warning Center's track has it making a near-direct pass over Iwo Jima on Tuesday afternoon, and then bending toward Okinawa late in the week. Its wind field is widening as it goes, and the forecasters watching it keep saying the same thing about that last detail. Its wind field is widening, much as Bavi's did last month. Bavi. 4 weeks ago, a Category 5 super typhoon put its eye directly over an island of 2,000 people in the Northern Marianas. Winds in the eye wall estimated near 180 miles an hour. And on that island, and on Guam, and on Saipan and Tinian, it killed nobody at all. Then it went west, weakened, never made landfall on the Philippines, and killed at least 23 people there. So when you ask what scientists are saying about this, there are really two questions, and the second one is the one that matters. The first is whether storms like Dolphin are getting stronger. The second is what actually decides how many people one of them kills. Because Bavi answered that question in a way almost nobody reported, and the answer is not the wind. I am going to give you both answers properly, which means not yet. We need to go through Bavi first in detail because the answer is sitting inside it. No guessing, no dramatizing, just the numbers, the mechanism, and the stakes. Before we start, have you ever ridden out a typhoon or a hurricane? Tell me in the comments where you were and what the sound was like, because people who have not been through one always ask about the sound. Subscribe if you want this kind of breakdown when the next one forms. And a thumbs up genuinely helps. Let us go for 5,000. Now, let us get into it. On the 2nd of July, the Japan Meteorological Agency upgraded a disorganized cluster of thunderstorms east of Guam to Tropical Storm Bavi. Nothing about it was remarkable. It was the 9th system of the season, designated 09W. Then it did this. In 18 hours, Bavi went from 70 knots to 125 knots. In the units most of you think in, that is 80 miles an hour to 145 in less than a day. By the 4th of July, it was a super typhoon by the Joint Typhoon Warning Center's reckoning and a violent typhoon by the JMA's. There is a technical name for this. Rapid intensification is defined as an increase in maximum sustained winds of at least 35 miles an hour in 24 hours. Bavi did nearly double that in less time. Here is what makes it possible, and there are exactly 3 ingredients. The first is warm water, and not just at the surface. A tropical cyclone is a heat engine. It draws warm, moist air off the ocean. That air rises, the moisture condenses, condensation releases heat, and that heat drives the circulation harder, which pulls up more moist air. It feeds itself. But a big storm churns. It drags cold water up from below as it moves. So if the warm layer is thin, the storm essentially poisons its own fuel supply within hours. NASA measured sea surface temperatures around Bavi's path at about 30 degrees Celsius, 86 Fahrenheit, and the warmth extended well below the surface. There was nothing for the storm to churn up that would slow it down. The second is low wind shear. Wind shear is the change in wind speed or direction with altitude. A developing cyclone needs to build a vertical column, a stack of thunderstorms wrapped around a center, aligned from sea level to the top of the troposphere. Shear tilts that column and tears it apart. Bavi had almost none. The third is an exhaust. All that air being pulled in at the bottom has to leave at the top. If the upper atmosphere lets it vent away cleanly, the whole engine spins faster. If it backs up, the storm chokes. All 3 lined up at once, and on the 4th of July, something happened that is worth knowing about because you will see it in the coverage of Dolphin too. an eye wall replacement cycle. The storm's inner eye wall was strangled by a new, larger ring of thunderstorms forming outside it. That weakened Bavi briefly overnight. Then the new eye wall contracted, took over, and the storm re-intensified, and came out the other side with a wider wind field. That is the trade. A storm that goes through an eye wall replacement often ends up slightly less intense at its core, but dangerous across a much larger area. Bavi made landfall on Rota in the Northern Mariana Islands at about 9 in the morning local time on Monday, the 6th of July, at peak intensity. The JTWC assessed 1-minute sustained winds of 180 miles an hour and a central pressure of 901 hectopascals. The JMA, which averages over 10 minutes rather than 1, put it at 125 miles an hour and 910. Both are correct. They are different measurement conventions, and you will see both quoted. The JTWC number is the one that maps onto the Saffir-Simpson categories Americans know. For scale, hurricane force begins at 74 miles an hour. Category 5 begins at 157. The lowest pressure ever recorded in a tropical cyclone was Typhoon Tip in 1979 at 870 hectopascals. Bavi at 901 was in genuinely rare company. The eye was about 29 miles across. Himawari 9 satellite imagery suggests the island of Rota, the whole island, was inside it. Rota has a population of about 2,000 people. It sits roughly 40 miles northeast of Guam. As far as the record shows, Bavi was the first Category 5 whose eye passed directly over it. Local authorities reported major damage immediately. Power poles and lines down, roads flooded and littered with debris, buildings damaged, a water distribution station hit. Communications were disrupted badly enough that assessing the damage took days. And nobody died. Not on Rota, not on Guam, not on Saipan or Tinian. Hold that. Do not decide yet what it proves, because there is a second half to this. I want to add one thing that makes the zero more remarkable, not less. Bavi was not hitting fresh ground. In mid-April, less than 3 months earlier, Super Typhoon Sinlaku had crossed the same islands. The JTWC assessed Sinlaku's peak at 180 miles an hour with a central pressure of 896 hectopascals, and it made landfall on the Northern Marianas as a Category 4. It killed 17 people. Damage exceeded $458 million. When Bavi arrived in July, parts of those islands had not been fully restored. Homes still had temporary roofing. Grid infrastructure was still compromised. Bavi hit communities already operating in a degraded state and still killed nobody. Now, Bavi left the Marianas and went west. And this is the part of the story that almost no coverage connected, and it is the reason I wanted to make this video. The storm crossed the Philippine Sea, weakened through a second eye wall replacement, and turned northwest. On the 7th of July, Pagasa gave it the local name Inday. It entered the Philippine area of responsibility on the 8th. It never made landfall on the Philippines, not once. The center stayed offshore the entire time, and the Philippines is where the people died. What Bavi did was enhance the southwest monsoon. Its circulation, over 1,000 kilometers across, acted like a pump, dragging saturated tropical air across the islands for days. Not a landfall, just rain and rain and rain. By the 13th of July, the National Disaster Risk Reduction and Management Council was reporting 20 dead and 16 missing. The Office of Civil Defense later put it at 26 dead and 14 missing. The consolidated figure now stands at around 23 dead and 18 missing, with over 650,000 people affected. Those numbers moved for a week as reports were validated, and I would rather give you the movement than pretend one figure was ever settled. Most of the deaths were landslides and drowning, and the worst single one happened at dawn on the 10th of July in a town called Malapatan in Sarangani province on Mindanao. A landslide came down onto two houses on a mountainside in Barangay Poblacion, burying two families. Rescuers reached the site around 6 in the morning. The mayor, Salwe Sumbo Jr., described what the neighborhood chairman told him, that at that hour he could still hear voices from under the debris. One man, 31 years old, was pulled out alive and died on the way to hospital. 10 people were killed in total. 2 of them were children. Now here is the part that belongs on this channel rather than a weather channel. That landslide was not simply a rain event. On the 8th of June, 32 days earlier, a magnitude 7.8 earthquake ruptured offshore of Sarangani. FEVOX put the epicenter 32 kilometers west of Masim at a depth of 33 kilometers. And the single highest shaking intensity recorded anywhere in the Philippines from that earthquake, intensity 8 on the FEVOX scale, very destructive, was recorded at Malapatan, the same town. 15 people died in Malapatan in the earthquake itself, and then 10 more died there in a landslide a month later. The mechanism is documented and it is not speculative. When strong shaking passes through a hillside, it opens tension cracks, fractures in the soil and weathered rock, often invisible from a distance, that break the slope's internal cohesion. The slope does not fail immediately. It stands there looking like a hillside, but water now has a pathway straight into it, and the strength that was holding it together is gone. Then it rains for 3 days. FEVOX warned about exactly this. In the primer they published on the day of the earthquake, they wrote that these cracks can make slopes more prone to landslides, particularly during heavy rainfall or aftershocks, and that areas at risk should be avoided. That was the 8th of June. The landslide was the 10th of July. The Malapatan Disaster Office said the same thing afterwards. Their officer, Mark Christopher Quino, said the ground had likely given way because monsoon rain fell on soil heavily weakened by the June earthquake, and noted, carefully, that a slope does not normally fail like that without pre-existing tension cracks, though they were still confirming it. That is a local official being more epistemically careful than most national coverage was. And it was not one hillside. The Philippine Space Agency had already mapped earthquake-induced landslides across Sarangani and Davao Occidental by comparing satellite vegetation indices from the 1st of June against the 14th, looking for slopes that had gone from green to bare. By mid-July, the Office of Civil Defense was convening emergency meetings with Glan and Malapatan about river damming incidents created by earthquake-induced landslides and worsened by heavy rainfall. I want to stay on that phrase because most people have never heard it, and it describes one of the nastiest hazards in this whole field. A landslide dam is what you get when a slope fails into a river valley and the debris blocks the channel. The water does not stop. It ponds behind the blockage, and a lake starts to grow where there was no lake. And the dam holding it is not engineered. It is a disorganized pile of soil, rock, and shattered trees with no spillway, no core, no compaction, nothing designed into it at all. These fail in one of two ways. Sometimes water overtops the crest and cuts down through the loose material, which unzips the whole thing in minutes and sends a flood wave down the valley, often onto people who have no idea a lake formed upstream, because it happened in terrain nobody can see into. Sometimes water works through the inside of the pile instead, quietly, until the structure gives way from within. Either way, the failure tends to be sudden, and the flood it releases is far more destructive than the river ever is, because it is carrying the dam with it. The dangerous thing about them is the delay. A landslide dam can sit for days, weeks, occasionally years. The earthquake that built it is old news. The community downstream has moved on. And then a monsoon rains onto it. That is what the Office of Civil Defense was meeting about in July, in the same province where those two families died. Not the landslides that had already happened, but the water piling up behind the ones that had. So, a storm that never touched the country killed people by raining on ground that an unrelated earthquake had already broken a month before. Bavi went on. It made its final landfall in Zhejiang, China, late on the 12th of July. By then, down to about 125 kilometers an hour. Taiwan was spared a direct strike, but took torrential rain. No deaths, 134 injuries, more than 14,000 evacuated. In China, 46 rivers rose above warning levels as the remnants moved north. Bavi dissipated on the 16th of July, 2 weeks after it was a nameless cluster of thunderstorms east of Guam. Taiwan is worth one sentence on its own because it is the third data point and it points the same way as Rota. A storm that close and nobody died in a place that closes schools and evacuates 14,000 people on a forecast. Which brings us to the question in the title. What are scientists actually saying? There are 3 answers, and they are more specific than the headlines. The first, the number of tropical cyclones forming each year has not meaningfully increased. That is the honest finding, and it disappoints everybody. The planet is not making more storms. What has changed is the mix. The proportion of storms reaching Category 4 and 5 intensity has been rising, and the physics of why is not mysterious. Warmer water at and below the surface raises the ceiling on how strong a storm can get before it runs out of fuel. The Copernicus Climate Change Service reported June 2026 as the second warmest June globally on record, and the Copernicus Marine Service reported that the oceans had their hottest June on record. NASA measured 30-degree water under Bavi. That is the fuel supply, and it is measurably richer than it was. The second thing scientists are saying is more operationally urgent, and it is about time rather than strength. Rapid intensification appears to be becoming more common, and rapid intensification is dangerous in a way that has nothing to do with wind speed. It steals warning time. A storm that builds to Category 5 over 5 days gives emergency managers 5 days of escalating lead time. A storm that does it in under 2 days does not. And the third thing is the one Bavi actually demonstrated, and it is the answer to the question I posed at the start. The wind is not what kills most people. Look at the ledger. 180-mile-an-hour eye wall passed over an inhabited island and killed nobody. The same storm, days later, weaker, offshore, making no landfall at all, killed at least 23, with rain. Rota survived because of things done in advance. Warnings issued days out in specific and unembarrassed language. Shelters opened before conditions deteriorated. Ports closed. Military bases postured, a population that has been through enough of these to take the warning seriously and be indoors before the eye wall arrived. That outcome was manufactured deliberately over years. Mindanao is what happens when a hazard arrives that the warning system was not built to catch. There was no typhoon landfall to evacuate from. The storm was offshore. What killed those families was a slope that had been quietly destroyed a month earlier by something with no meteorological connection to the storm at all. And although FIVOLCS had named that exact hazard on the day of the earthquake, Translating a scientific warning into 10 specific families moving off one specific mountainside is a much harder problem than closing a port. That is what the scientists are saying, and I would put it this way. We have become genuinely good at surviving wind. We are still not good at surviving water landing on ground that something else already broke. So, what do you do with this, particularly if you are anywhere in Dolphin's path? Know your actual hazard, because it is probably not the wind. If you are on a slope or below one, or on a floodplain, water is your threat, and it arrives with less warning than the eye wall does. And if there has been an earthquake in your area in the last year or two, that changes your slope risk, and it stays changed. Look uphill from your house. Tension cracks, fresh, bare patches where vegetation has gone, tilted trees or fence lines, small slumps, new seepage where there was none. Those are the signs a slope is already failing slowly. Report them to your local disaster office. In the Philippines, the barangay or municipal DRRM office, which is exactly what they asked people to do. Act on the day 3 warning, not the day 1 impact. The only reason Rota's number was 0 is that people were in their safe location before moving became dangerous. The Western Pacific is the most productive tropical cyclone basin on the planet and always has been. It was making these storms long before anyone was there to name them, and it will go on making them. What is under negotiation is not the storm. It is the state of the ground when the rain arrives, and whether the people standing on it were told, in time, in words they could act on. Dolphin is out there now, gathering. Iwo Jima on Tuesday, Okinawa perhaps late in the week. Its wind field is widening, and the lesson of the last 4 weeks is that the warnings worth acting on will not feel urgent yet when you get them. Tell me in the comments where you were and what it sounded like. Subscribe if you want the breakdown on Dolphin when it lands. And thank you for giving me this much of your afternoon. I will see you next time.